Hello again, math students. This is Matthew Williams, and today I'm going to show you how to solve square and cube root functions algebraically. Now, real quickly, let's go through some definitions. So, what are we dealing with? We're dealing with radical equations! We yell it that way because, I've written it as 3 exclamation points, right? So, what is a radical equation? So, a radical equation is simply an equation with a radical expression in it. So, this would be an example of a radical expression with, x plus 2 being expression. So you're probably wondering, how do you solve them? It's a simple 3-step process. So you isolate the radical on one side, so anything that's not the radical, and then you raise each side of the equation to the power of the radical. And then whatever is left over, you solve that. But wait, because you're not done. You check your answers by plugging in the x value that you got right here in step 3. Based on how this statement is true, 9 equals 9, this solution is for sure not extraneous. So you're probably wondering, what does extraneous mean? And why do we check like that? So extraneous solutions are numbers that don't satisfy the equation. Basically, the end of the problem will tell us this. If this statement right here is true, then it's not extraneous. But if this statement is incorrect, for example, 4 equals 5, then it's considered an extraneous solution. And after this, we do not attempt to look for other solutions. It's just simply no solutions, which can also be written as this little 0 with the little cross mark in it. Let's try some practice problems. So here we have x plus 3 minus 6. What's our first step? Okay, so right now we're going to isolate the radical like this. And so what we end up getting is x plus 3 is equal to 2. So now we square this, as it says in step 2. And so this ends up being x plus 3 equals 4. Now, all we have to do is subtract 3, and so our answer is x equals 1. Now, keep in mind, we are not done. So you see this original equation right here? We're just going to check it like this. So we've got 1 plus 3 plus 6 is equal to 8. So here we have square root of 4 plus 6 is equal to 8. 2 plus 6 is equal to 8. 8 equals 8. Now that we see that this statement is true, this is not extraneous. And so what you're going to do is, now that you know it's for sure not extraneous, you're going to want to box your answer, because your answer in step 3 has just confirmed to be true. A mistake that I made, I didn't realize, was that I worried about finding a different solution after the extraneous solutions, but we'll get into that later. Let's move on to other problems. Okay, so our next problem is this one. We're dealing with cubed roots now, so keep in mind that we're not going to square it this time, we're going to cube it. So we've got 6 plus 6, 12. So we've got 3x plus 3, and so this gives us, of course, 12. So we're going to divide by 3. So we get cube root of x plus 3 is equal to 4. And we're going to cube this, so then it becomes 64. And we subtract 3, so it becomes 61. Right, so now we got to check this. We're going to go over here to where it says check. Now 61 plus 3 minus 6 equals 6. 3 cube root of 64 minus 6 is equal to 6. Now, we have just learned with this problem that the cube root of 64 is 4. So from here, 12 minus 6 equals 6. So 6 equals 6. This is true. So what we're going to do is box, our answer that we got in step 3. And then we're done. Now this next one is a little bit more challenging because you got 2 radicals and they're on both sides of the equation. Now since we have the radical isolated on one side of the equation, we don't have to worry about doing step 1. So we're just gonna square both sides, right? So this becomes x plus 20 is equal to, we're gonna do some foiling. So it's 10 plus root x, 10 plus root x. 100 plus root 10x plus root 10x plus root x squared. Now we just simplify. So 100 plus 20 root x plus x. Because when you have a square root and a square, they cancel out. And so what we're going to do now is subtract our x's, subtract this, and we've got negative 80 is equal to 20 root x. Then we just divide that by 20, and so we get negative 4 is equal to root x. So now we're just going to square. So for our final answer, we get x is equal to 16. Now let's check this. So our original equation is 16 plus 20 is equal to 10 plus root 16. We've got root 36 is equal to 10 plus root 16. Well, we know root 36 is 6, and we know that root 16 is 4. So we got 6 is equal to 14. So this doesn't look too right. So, since this statement is untrue, we do not box this answer. We put no solutions, and we box it, or you can write that little and box it. Either one is fine. Okay, you guys, so I have 2 more things I need to show y'all. So the first thing is some tips on being a good math student. And it may help to write the formula or steps associated with the concept in the first couple of problems you tackle. It's really helpful, I think, for memory. And I'd say you need to pay very close attention when a teacher warns you of an instance, where there tend to be a lot of mistakes in that problem, because that's pretty valuable, and it's awesome that the teacher is giving that to you. And if there's a formula that you think you're not going to remember, then make a flashcard or put it in a Quizlet. That way you'll remember it, and it'll be all good. You'll be covered, really. Okay, so a quick recap. That's the second thing. Radical equations are equations with radical expressions. So x plus 2, the stuff that you saw. When you solve radical equations, you isolate the variable on one side, you raise each side of the equation to the power of the radical, and then you solve the equation. And then you check, and if it's an extraneous solution, then you just write no solutions. Of course, an extraneous solution is when it doesn't, when it's incompatible or doesn't support the solution. And pay attention to the difference in types of equations. And honestly, you guys, that's it. Thank you guys for watching, and I hope this helped.